Okay, so good morning and welcome to yet another very, very exciting edition of Tech Talk. And for those, for those who are joining us from outside of Guidewire, just a quick note that Tech Talk is essentially a platform or a forum where we get together with peers, partners, industry experts, and essentially, engage with them, ponder and talk about what are the advancements in technology, what can we do better, and what can we learn from the experiences of others. Okay, and today we have a very exciting talk lined up ahead of us. And before the talk, I was just asking Murli, like, I'm not a techie, so what exactly is this topic all about? And he said, this is like, you know, so essentially now with our, transition to cloud, cost is essentially like, having an elephant in the room. And this elephant is there in every industry, across every industry's boardroom. And he gave me a very interesting example. He said, when you have $100 in your wallet and you spend $100 and that $100 is over, you know that the money is done. Whereas now with cloud, it's like swiping a credit card until the day that the credit card bill hits you and you're like, oops, I don't have this money. We don't, that's where cost, the issue of cost is what we are all tackling with. And today we have a very esteemed, interesting speaker from who's joining us from AWS. Huge round of applause to Gautam, who's joined us here today. And along with Anup and Murli, who, I mean, we are all familiar with Anup and Murli. They've come all the way from US to help us. But today's session is essentially about this particular black elephant that's there in all the boardrooms, okay? And so over to Anup to start our tech talk. Anup, over.
Thank you, everyone. Very good morning, and thank you for being here on a Friday. I know this is probably not the best time to have a tech talk, or maybe it is in Bangalore. First of all, thank you for the introduction, Lakshmi, and the topic itself. I myself, as a VP of engineering, I've been working with Guidewire since 2018. We started our cloud platform, and I lead that as for the global GWCP, or the Guidewire Cloud Platform, which runs most of our insurers in the cloud. As part of this process, I've also seen a lot of ups, downs, challenges, opportunities, and all of them came with one thing in the end, which all the people upstairs to me were interested in. Are we increasing our revenue? Are we reducing our cost? And to be honest, anytime you start up a platform, and we started as a Kubernetes platform, but then it is not just about a platform. Anytime you do a cloud adoption, your idea about what it takes to build a platform is very minimal. And when you do that, let me also go through that. When you do that, you realize that cost is not something that comes very easy. Now, I have our AWS guest here. There are a lot of tools in AWS that will help you identify costs at the aggregate level, right? Be it at the RDS, be it at EKS, etc. But then you run all your workloads within teams that are myriad in Guidewire. How do I show back these costs to all of these teams? How does everyone know how much it takes to run their workloads? That has been elusive for quite some while, but now we have great tools that are available, which both Murli and Gautam will speak about pretty soon. And I don't want to get into those details. And like I said, the industry trend, I'm not going to speak about what these CEOs are saying. Everybody cares about cost. And like I said, as you build a platform, you're spending your time, you're spending your cost, building it, proving the platform. The cost curve is pretty steep. At some point, you're going to stabilize the platform and you have everything done to a reasonable level, or so you think, right? And then the cloud moves ahead. This is something that forces your hand every now and then. We have a lot of people here who have been on the Guidewire Cloud journey. How many of you had to update or upgrade your systems so many times because it's forced on you from the outside. Awesome. I see a lot of raised hands. I'm assuming it's the same ratio in the Zoom as well. So cost, again, coming back to cost, it is not, when we say cloud cost, it is not just the cost of doing business through AWS or any cloud provider. It is also the cost of running the business through human effort. If your cloud platform needs 1,000 people to run, it's not necessarily, you might be reducing a cost in AWS, but you've moved all your cost into the human capital. That is another thing that you need to look at how to reduce it over time. Now, how many of you have heard of Werner Vogels here in the room? One. Of course, if Gotham didn't, that would be. He's an amazing personality. He's also the CTO of AWS. Recently, he's still a CTO, right? He's recently wrote a blog post on frugal architecture. There are, these laws that he's postulated, which are amazing. They're simple in nature. It's not like rocket science. Each of these laws you can take to heart in everything that you do. And it is not just about building a platform. It relates also to building an application. How you think about building an application. How do you think about building a system, be it even operative system, security system, any of those. Now, going through these laws, I just want to, I'll do a quick rundown of these laws, but it's done much better on his website. So first law is make cost a non-functional requirement. Why do we stumble in cost? Why do we look at cost at the very end? And then, like Lakshmi said, you get a huge credit card bill, and we're all surprised. It's because we've never been looking at it from the beginning, right? If you set something up as a non-functional requirement, this is all, for all the PMs in the room as well as on Zoom. How do you allocate non-functional requirements for cost? And doing that will help you gauge how much is a new feature going to cost you eventually, and what the run up to your total cost is going to look like. The second is systems that align costs to business actually do better. When you architect your systems, you have to align cost to your business. Do I use EMR versus Spark on EKS? Do I use RDS versus a Postgres container in EKS? You have to align. Do I need all the bells and whistles in a dev environment? So these are all levers that you have. You should align towards business, because in the end, you're going to cost something. You cost yourself just as much as you price to your customers. How do you make effective use of those levers to run business effectively? Architecting is a series of trade-offs. No denying that, right? So you have to figure out, if reducing cost is going to take you a year to reduce $10 of cost, not worth it. Simple, but effective. Unobserved systems lead to unknown costs. Measuring anything is important to a business. Your costs, your revenues, your human effort, all of them. So unless you know how much you're spending, and you're observing them on a regular basis, you're bound to spend more. Again, going back to Lakshmi and Murli's credit card bill. If you're looking at your credit card, statements once in a while, you know what you've spent on, what your aggregate cost is going to look like, and then you can adjust the rest of your spend accordingly. So observe. Cost aware architectures implement cost controls. This is very similar to the law 2 as well, where I was saying, when you're cost aware, you implement controls like, hey, in dev, I probably don't need all of these bells and whistles. Or maybe in dev, I can shut down my systems as soon as I'm done with my testing or when I use it. I don't need the system to run when I'm asleep, or my team is not working in that time zone. You could do all of those things, and you could build systems that are cost aware and are able to build on top of the cost architecture overall. And the last one, cost optimization, is incremental. Nothing happens in a day. Rome wasn't built in a day. It takes a lot of effort. It is something that has to be continually looked at. And this is for each one of us. So what has been our approach? The first approach that we've been taking in Guidewire, and this is still ongoing, is about attribution. How do I attribute these costs to teams, efforts, capabilities, or features that we're building? Who is the owner of that? How do I spit out reports that help me understand the cost of running one program versus the other? How can I do the analysis based on cost effectiveness of one feature versus the other? So attribution is the first step of all of these things. Who is doing it and what and when? The second is visibility, at what level. Now it's good for me to say, Satish team is spending X amount, but then where is that X amount being spent? Is it on the database? Is it on EMR? Is it on the microservices? So being able to go granular and be able to attack where the cost can be reduced is important. That's the visibility that we'd like to provide. And then obviously the last step is, how do I optimize these? Right size environments, make sure you're not requesting for more resources than is required by your system. Turn off when you don't need it, which many of us, for the lack of better systems to do, we don't, right? Our workloads are running all the time, even when we are sleeping, when we don't need it. How do I make sure and design to shift left, which is make cost everybody's concern right from the beginning, at the source, unless it becomes an important aspect of your feature right from the beginning, the cost overruns are almost always possible. With that, I'm going to hand off to Gautam, who's going to give a good introduction to all the attributions. But before that, I have a question for the group here, which is going to come with a prize that Lakshmi is going to give out. Considering all of you guys know about ChatGPT, anybody here who doesn't know about ChatGPT? Okay, sorry for the folks in the Zoom. So is ChatGPT an AI or is it ML? Any other answers? The answer is the AI. It uses the ML models to use the data and then give you an application on top of all of those things. So it is considered AI. Sorry, nobody won that quiz. Both doesn't count. All right. So yes. No, not at the level. So those are different levels, right? It uses GPT-4 as probably a statistical model, but the application is, as far as I understood, is AI is where you use the application at a business level or a capability level, whereas ML is a specific area of AI which focus on statistical models and how the mathematical models and running them on specific data is. Again, debatable, but this is my answer. All right, passing off to Gautam.
Hey, good morning, folks. Quick intro. My name is Gautam. I'm a senior container specialist TAM with AWS. I work with the enterprise support segment, meaning I help customers optimizing their day two operations in Amazon EKS in terms of optimizing their Kubernetes workloads by doing proactive reviews, deep dive sessions, one-to-one, one-to-many. Also contribute to public speaking, also few blogs here and there. That's about me. Follow up to what Anup spoke in terms of attribution, we'll try to understand what are the different cost dimensions. So let's sort of step back now. Today, you have microservices, you are on Kubernetes, we are good. But let's say you were running or you still run monolith environments. You would be running on cloud, you would be running on on-prem, bare metal. you know what's the cost dimension. It's more of 1:1. You run your app, you know what's the cost of that compute, you have the number. But when it comes to Kubernetes, it's pretty different in terms of you run multiple containers or process or microservices in one given compute. Now, how do we narrow down to understand, hey, what's the cost that my cluster is giving or the data plane? Now, the key dimensions here would be, we'll start with the platform because you're running on Amazon EKS. So with EKS, you have two layers. One is your control plane, where AWS manages it for you in terms of your API server, your HCD, any control loops that runs in control plane. The cost for that is pretty simple, $0.10 per hour for your control plane. Now, let's say your leadership team, your managers run cost reports. They said, hey, I know what the control plane cost is, but how do I know what's the compute cost? Now, where you run your containers is the compute, right? Now, again, talking to the topic on Cost Explorer, let's say you run cost usage report, you go to the EC2 cost, you would see wide range of costs. Now, how do I narrow down what's the compute cost that's associated with EKS cluster? That's the key thing that many customers asked. Sometime back in 21, 22, EKS allowed tagging. For example, we'll see that more in a bit where Murli will speak how Guidewire is using it. But in terms of understanding compute cost, you can tag those with your cluster name. Let's say you have 10 different clusters with a specific tag name called EKS cluster name. You would narrow down what are the EC2 cost or your compute cost or the data plane cost associated with one specific EKS cluster. So that's where your compute cost understanding would be the key. Now, you might ask me a question, hey, I'm good with control plane cost. I understood what's the compute cost, but I'm still running containers. How do I know what's the cost of running one container or 1,000 containers in a Kubernetes cluster, right? Before going there, again, for the folks who are pretty new to Kubernetes, high level, like I called out, you have, in terms of architecture, you have control plane and data plane. Control plane, like I called out, it's managed by AWS for you. But in terms of data plane, that's where you run your workloads, right? Now, what are the workloads that you run natively in a Kubernetes cluster? You would run your pods, you would expose them as services, you would run your load balancers, ingress, wide range of resources. Now, we'll start, we'll go to the workload cost, but in terms of cluster cost that I called out, right? You can tag your clusters and get to know what's the cluster cost. Now, how do you aggregate both? The cluster cost would be your control plane cost. You know the number, $0.10 running hour for your managed component. For your data plane, leverage tagging, narrow down what are the EC2 compute cost. In terms of some of the options that you can optimize, we'll again speak in the end where Murli would cover how Guidewire is using it. But in terms of container cost or namespace cost, you have wide range of tools today. For example, you have Cube cost, where Murli is going to speak in terms of how Guidewire is using Cube cost and different tagging resources and how we have got to the cost granularity. So quick recap in terms of cost granularity, it's your cluster cost, your control plane, your compute, where you tag, and then at your container level, based on different labels or tagging, with Cube cost, we'll see how Guidewire is using and how we have leveraged it. Thank you.
Thanks, Gautam. So as you can see, I come up with some small gift because I'm not going to ask controversial, difficult question like Anup. He's a techie, so you can expect those questions. Easy question related to the topic, but I'm sure many of you know. One disclaimer, nobody from Anoop's org answered this question. So all of us have transitioned in one way or the other, been in the industry, looking at VMs, data centers, and so on and so forth. Now cloud, Kubernetes, right? Anyone, any example is, or any feature is fine. Why Kubernetes? What is an advantage of going to Kubernetes? Anything. Scalability. Awesome. Anything else? Container orchestration. Ease of provisioning. Awesome. I'm sorry. High availability, great. Anything else? Cost reduction, awesome. He comes to the topic. Set of features that Kubernetes provides. This seems to be not really an answer. This is like a set of yeah. And you are in Anoop's org, so disqualified. Anyway, jokes apart. Thanks, Raman. If the size is not fitting, you can donate it. You should not have answered, Raman. Cool. So first of all, thanks everyone who are on the Zoom. I know some of you who are outside of the India time zone are there. I appreciate you guys joining for this tech talk. We planned in a short span of time. I really do appreciate Gautam, industry expert, joining us from AWS. Thanks to Anup, he's here, and it's an opportunity for us to hear from him. And thanks to everyone who is here on a Friday, showing up in the office, because most of the time we are doing remote. So with that being said, quick intro. My name is Muralicharan Gurumurthy. I'm in Guidewire for almost last 10 years. I started off working on application development, then doing what we called at that point in time DevOps, a lot of tools, managements, and at some point when Anup joined for cloud transition, as he talked about, I joined with him. It's a great journey so far, a lot of learnings. So I didn't know Kubernetes, whatever, six years ago. So all the learnings is from Anup and team. I also want to extend my thanks to all the teams who are here, all of Guidewire, who are receiving what we are delivering, from platform teams. We can keep delivering a feature, but it's like, disrupting or changing the way of how we operate. So thanks to everyone and the teams who are sitting in US plus Bangalore office, who are implementing all the good stuff that Anup and I are going to talk about, right? It's just, we are only, leading catalyst, but it has to be, execution is more complicated than just coming up with an idea. So thanks to all. With that, further to what Gautam said, right? In terms of getting visibility, I want to know, we all get a name because we want to identify ourselves, right? So without a name, we all can be, given like human 1, human 2, human 100. It's difficult to manage. So that's how the name starts, right? Likewise, in the journey of how we want to optimize cost, that's how it comes. Anup's boss is asking, Anup, so much being spent, do something, right? It starts with who is spending what? No idea, or limited idea. With some people have adopted some model of tagging. AWS advocates a way of tagging, so maybe some teams have implemented that. So there is it existed in some shape and form, not in a unified way. So we leverage, as again both Anup and Gautam talked about. We built on top of Kubernetes. On the get-go, we decided it's going to be on Kubernetes platform, all container workloads. That doesn't mean that only container workload is what we have. We will also have workloads outside of containers, like RDS, databases, and so on and so forth. So start off with the tagging, influenced by Kubernetes, obviously. So what you see is from the left side is the snapshot from Kubernetes documentation, or both from Kubernetes documentation. Just giving a simple example. We derived from that. We have influenced by that, derived. And what we wanted to ensure, when we give this naming, I don't want to give different styles of labels and keys and how we orchestrate. Meaning, if I give a key, how we call something in Kubernetes, the labels, it should also map to what's running on AWS, so that tomorrow I can map both of them. So this namespace, we'll talk in a little bit detail. This namespace is running this type of load, and I'm able to find the cost in Kubernetes, but I also want to see that namespace is using this database, and that database also should have a right name, so that I can correlate both of them, and then I can produce a unified cost, which we'll start talking about when we get into the tool. I'm going to go a little bit fast in the interest of time. So this is more of our journey, how we implemented, unification of defining the standards, as we just talked about. And then we kind of started enforcing the Kubernetes labeling. Initially, we asked teams, and at some point we enforced, if they don't have the standards, they can't even deploy. So for people who are in the room or in the Zoom, if you are playing a orchestrator or administrator sort of a role, you can employ these techniques with amazing power that Kubernetes gives. I can stop the deployment, right? I give you some time, 3 months time for you to implement these labels. After 3 months, I'm going to stop your deployment if you're not following these labels, and so on and so forth. So keep going. It took some time for us to unify the entire organization, because many different teams are doing a lot of great stuff. So it's important that we tag, across the board resources. So at some point now, okay, everything is tagged. Awesome. So this is just like giving names. We all got names. Now, how do I see it, right? How do I see how many people are working in Guidewire? How many people are in department A, department B? So we want some sort of a dashboard, some sort of visibility. How do you want to get the visibility? Initially, we started creating, these are all actual screens, emails that we send to department leaders. We first started off with, at a department level, let's start aggregating cost. Both Kubernetes cost, I want you guys to be very clear. The cost when we start talking about is stuff runs inside Kubernetes, and there are stuff runs outside of Kubernetes, like I said, RDS. So we want to grab both. We wrote our custom code in Go. We'll talk about Go as a separate tech talk. We produced reasonable, okay-ish graphs and emails that you see. And then we also had other ways of notifying how if the tagging is not done by people, ping them on the right channels in Slacks, notify them, nudge them, etc., in the process of that 3 months or so, right? And then at some point, we want to make it much more easier. Slack, people may not be, there are nowadays 100 Slack channels we are all part of. Ding, 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 ding. We are not able to respond to whether I should respond to Slack or do my job, then it's a tough question for all of us. So we have to give something much more simpler for people. It can't be an intelligence. Our team only knows holes, ping APIs, get the report, and then ping somewhere in Slack, send an email. Again, we get 200 emails. So who is really watching that email? So how can I make it much more simpler? AWS provides AWS console, right? If you want to, once you want to know something on AWS, just get into the console. It's a unified view of all the services of AWS. It's amazing, right? Likewise, KubeCost is the tool that we have leveraged. There are many different tools in the market. We have evaluated different tools, and we finally settled on KubeCost. So rest of next 5 minutes or so, I'm going to talk about KubeCost and how we leverage the KubeCost. So KubeCost is a tool which is going to give us a comprehensive view of the cost that's running in both Kubernetes and stuff runs outside of Kubernetes. And again, it gives different views of all the good stuff, which we'll get into that. So again, our goal was the last statement. Everyone in the organization, everyone in the developer or community who are developing something or deploying something into the cloud, into Kubernetes, should have visibility using a tool, and that tool of choice is KubeCost. AWS also have a partner with KubeCost. Again, maybe I'll let Gautam talk about it when he comes back. KubeCost has a lot of different options. If you understand in any company, anybody, be it only product development or when we expand it to customers and production ecosystem, I don't think nobody's running with one single particular Kubernetes cluster. There are different needs. I could have a Kubernetes cluster for dev. I could have a different Kubernetes cluster for integration, staging, and then keep going productions and so on and so forth. There's always multiples of Kubernetes clusters that we are managing. However, if you think about Anoop's department, he has set up like X number of clusters for product development only. He would have X number of clusters for customers, development ecosystem, customers pre-production, customers production, and again, you can expand it for respective companies and how you have slice and dice, right? What KubeCost can give an holistic view of entire cost ecosystem, where you can go down to what you see on the top. These are all sample slides, not actual data I cannot show. So that's why I changed from live demo to the slides I got from KubeCost team. I don't know if anybody from KubeCost is here. Jeremy, if you're here, thank you so much. Yeah, maybe I don't know. Jeremy, maybe type and let us. Oh, Jeremy is here. Okay, maybe Jeremy, I'll let you hear. I would be interested to hear from you for probably a few seconds towards the end. Thanks for your help. So it can give us the holistic view of both Kubernetes and the cost of entire cloud that you're running, provided you have done the right tagging, right? First name properly, then you can call your kids. Again, I'm not going into the details of every single slide and the features, but again, once you start exploring KubeCost, you'll see the power of what it can do. It can give us the holistic view of all the clusters. Like I said, if Anoop's department has 7 clusters that he's responsible for, then I can drill down to every single particular cluster level and how much cost is being spent, how much it can be saved. KubeCost has intelligence based on heuristics. It looks at your usage and so on and so forth. It gives us a lot of insights on how much is requested, how much is used. So basically you can figure out and then drill down to a namespace level. Because of family Kubernetes, then go down to namespace, then go down to pod, go down to containers. It can go down to many different levels in terms of giving you a visibility at a particular container or pod or namespace level, where you can see how much I can save and go down to the container level and figure out how you can reduce your resource utilization. Multiple aggregations are possible. One of the common problem that we have in the world of calculating cost is a shared cost. Networking is across the board. How do I slice and dice? Maybe a database is used by multiple services in development ecosystem. That's probably common. Each of us share, a DB, but we have a single RDS cluster. So there is a way that Kubecast has provided, and they have evolved a lot amazingly, where you can provide a shared by cluster, shared by node, shared by particular workload, and what is shared, and you can even give a what is the overhead of percentages and how you can split the cost. Again, a lot more granular options are possible. Latest recent feature includes auto-completing some of the labels. Again, labels correlate that to the tagging that we have talked about, right? So we provide labels. Previously, we had to type the labels. You have to remember the labels. Now it's like autocomplete is amazing, and it gives all the filtering options pretty nice and clean. Like I said, the unified cost monitoring, the concept of collections provides us capability to merge both Kubernetes workloads and then workload that is running outside of Kubernetes. Again, I'm not going to go into the details of this. If anybody's interested outside of this talk, feel free to ping me. Happy to show or drill down into the details. Again, so as you see here, it shows you the total Kubernetes cost. It shows you the total cloud cost. Whatever it says cloud cost refers to stuff runs outside of Kubernetes, right? And efficiency and so on and so forth. Forecasting. Recently, Kubecast 2.0 plus have introduced a forecasting concept where from your trend, since if you have employed Kubecast running in your cluster for a reasonable period of time, I don't know if it is AI or ML, I don't want to get in there, but at least it will give you a forecasting based on your trend of usage that you are going to grow in the way how things are flowing, right? 6 months ago, I've been running 2,500 containers, and now it has increased to 3,000 containers or 4,000 containers. So they're able to project. This is just a simple example I gave you, but CPU, memory, lot more complex, analysis goes into that. It gives you a forecasting view. It's a very nice capability for FinOps and leaders to look at it. Hey, if this is running like this, where will it be at the end of the fiscal year? Are you going to be stable? Are we going to be exponentially growing? So that's going to be a nice, cool feature, which is a common question asked by leaders. And granular cost reporting is possible using, again, Kubecast. You can go down to the container, like I said. It'll give you very specific container level resource, CPU, memory, and so on and so forth. You can also see, again, we are talking about cost, right? Every single thing is broken down to finally how much you'll save, how much it's burning, how much you can save if you implement, measures of changing, right? Total cost is so on and so forth. What I like most is this screen. So there's a screen for savings. If you get into that, it'll give you options and give you an actual dollar figure. Whether it is possible to save exactly that amount or not, it's based on how your application profiling works. Gautam will talk about it later part, and how you can optimize. Are you okay to change some of the design and architecture of your application? Again, there are a lot of other bells and whistles are involved, but at the same time, Kubecast is able to predict to a reasonable extent how much you can save in your particular cluster, where you can resize the nodes. A very common concept that all of you know is AWS has different instance family, instance type. While AWS has given the power to us with a lot of instances, AWS is not going to tell you which instance you have to pick, because you are architecting your application, you are designing your application. You should know your application is CPU heavy, memory heavy, and which family of instance that you want. But at least it will give you a recommendation based on the instance running or based on your application running inside Kubernetes. And Kubernetes behind the scenes is using the EC2 nodes. So if I'm using M5 XL, but your applications are extremely memory heavy, maybe it will propose you a different instance type that you can use. Just one example of the first panel that you see. And likewise, there are many options. Container level right sizing is possible. An amazing capability here, even we still have not tried it, where it will show you all the container level optimization that it can do. I don't know if you can see clearly here, but I can read out. So what it shows for a particular container is it has requested, CPU requested currently is 100 M, and CPU recommended is 10 M based on the usage, as you can see in the graph here, right? Likewise, memory requested, memory usage is 18.42 M, while memory requested by the application owner is 50 M. So basically, you have asked for more, but you don't necessarily need that much based on the usage trend that Kubecast have analyzed. So it can give you a power, press a button, it can go change the entire ecosystem on the cluster to resize to your needs. Again, you have to think about resizing involves few other, application restart and things like that, which is what we are going to think and optimize. Again, skipping through quickly, there are options to do governing with budgets and set limits, audits. It can give you alerts and so on and so forth at a department level or different level that if you're interested. Anup will talk about network optimizations a little bit. It has given a power of network cost and visibility, which can again be shared, and you can have a mechanism to slice and dice. So some of the screens I have taken from Jeremy, what I have showed you guys shows you a lot of power that you can get from Kubecast. Kubecast is running in dev ecosystem currently as you speak, is running in across all the ecosystem of Guidewire, right? So many different clusters. So what I would request, which Anup will summarize at the end, any role that you perform in the organization, inside Guidewire, outside of Guidewire, doesn't matter. If you have Kubecast or equivalent tool, it's not somebody else's responsibility. It's not FinOps or somebody's responsibility to take a look at spend that's going on. You can go look at your namespace, your applications, your service, your container, and see how you can optimize. If you don't need it, you don't need to use it. So that's what Kubecast can help. Hey, Jeremy, do you mind unmuting? Anything else you want to add? If you're still around.
Yeah, absolutely. Thanks so much for the demo and the presentation. I will add that, a lot of new features are coming on the roadmap, such as GPU efficiency tracking, getting more granular views into AI and ML-based workloads. Carbon footprint has also been a pretty big interest from our community. But again, thank you to the Guidewire team, yourself, and the rest of the team for helping us really shape the future of the KeepCost product roadmap. And if there are any features that you would like to see or the team would like to see, please feel free to share that feedback with us. And we're happy to partner with you on future collaboration on this roadmap.
Absolutely. Thanks, Jeremy. So we didn't plan this quite sooner, maybe my fault. Otherwise, Jeremy was saying he would have flew here to talk about some of the Kubecast stuff. He's based out of US. Thanks, Jeremy, for the partnership. We have been working with Kubecast for almost last 2 years. So we have evolved a lot together as a company, like our partnership with AWS. That being said, I'll stop talking. I'll hand over to Gautam to talk about optimizations.
Yeah, thanks, Murli. So we understood attribution, then we went to visibility. Murli explained in detail how Kubecast has helped Guidewire in sort of narrowing down what's your cost breakup till your microservice or your container level. Now, this is good. Okay, we got the visibility. Now, like what next? Would be in terms of optimizing, right? Now, there's a slide in the next that I'll speak how in terms of load test and different application profiling you can get to it. But this is one of the report from Datadog that says 49% of containers use 30% of requested CPU, meaning you can provision a bigger compute machine, let's say 2x, 4x machine, and you ideally don't use the entire resource of that compute. For the folks, again, coming from legacy, CPU utilization is not same as resource consumption. In Kubernetes, it is all about resource consumption. Let's say there is a compute that can give 4 cores of CPU. Either you can run one container consuming all 4 cores, or you can run 100 containers asking 4 cores of CPU. Now, let's say you're running 100 containers, all are asking 4 cores of CPU. Let's say another container is landing in, your Kubernetes scheduler wouldn't place that pod on that specific compute. Meaning utilization is not same as resource consumption. Now, if you have a question, hey, how do I understand how the resource is being consumed? So whatever tools that you saw in terms of Kubecast, in terms of right sizing, you have something called request and limit, which we'll see in a bit. That is the key parameter that's going to tell, hey, I'm asking X amount of resources from a compute, and Kubernetes is guaranteeing you, hey, I'm going to give that much amount of resource. Now, what is limit? Limit is like, hey, I shouldn't exceed or I shouldn't consume entire resources of the node and bring up the compute down itself. Classic example would be, let's say you're running a Java-based application, which is memory intensive. Now, let's assume you're setting a request and telling, hey, give me this much MI of memory, but you're not setting a limit. And let's say that mission is having a cap. This is max I can give. And let's say this Java process is continuously asking memory. It can eventually bring down that specific node or compute. Meaning it can kill the kubelet, which is the daemon that runs on the node, and say, hey, take the resource for this Java application. So for any memory intensive application, setting a limit is a key. For CPU, it's a different discussion. Should I set a limit, not a limit? There's a nice blog that I can share in the end for the folks who are interested. In general, for CPU workloads, setting limit is not recommended, but there are two sides of discussion to that. For memory workload, you would have to set a limit. One of the customer use case in similar lines to this specific dump where we worked closely, we could see in their non-prod cluster, they had provisioned very high compute and they were not even using 10 or 20% of the resources. Like Anup called out in the start, and also Murali spoke, like it's on waste of resource. Like let's say end of business over the weekend, you're not running it, you would have to bring that down. We'll see how that can be done. In lines to what we spoke in terms of the Datadog report, predominant container workloads are underutilized. You can have a question, hey, how do I optimize it? You're talking about optimization. How do I get to a right value? One of the key thing would be your observability or monitoring stack. Kubecost is giving you recommendations. Hey, this is the request. Over time, this is what it is using. You can also validate that in your observability stack. This is one of the snippet from Grafana dashboard that shows, hey, over time, this is how a specific application is using CPU resource and also memory resource. Based on this, you can go about narrowing down, should I really give 3 cores of CPU for this workload or should I reduce it? This is basically into application profiling. Now you can have a question, hey, how do I get to that right value? You have Kubecost giving you that. But if you ask me, let's say sort of step back, and there's something called sweet spot within every application, something similar. You can start always with one container on one compute, do an extensive load test and gradually increment those containers. You will see a breaking point of the application. Hey, you're giving 4 cores, but I need 5 cores. So that's something called a sweet spot for every application where you can derive at, okay, what's the right request I would have to configure, be it be CPU intensive or memory intensive application. Cool. How do we get there? So this is a nice wheel I generally explain customer, like Anup and Murli called out. It's not just a platform or a SRE's responsibility in terms of, hey, go set this request. It's like in tandem, like you would have to start with your application team, tell them, hey, over time, this is what I'm seeing the trend of the application. Either you are asking more resource, which the application doesn't need, or there could be other flip around. You're asking very less resource and you're actually throttling the compute. So you would have to always do some sort of hypothesis, run experiment, do load test. Coming back to the loss of the cost architecture, it is always incremental. You would have to do some amount of load test with your application, keep tuning the request value and see, okay, what's the right, and that would directly impact the compute that you're going to run and optimize or save cost for you. Cool. We'll understand right sizing. Before we get there, for the folks here in the room, can someone tell, like, what do you understand with requests or limit, or have you set in your workloads? This is one of the snippet, but whatever you understand from this slide, if anyone can. Mm-hmm. 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 That means when the container runs, it will get minimum 64 MB. Yep. That's guaranteed. Mm-hmm. Mm-hmm. So, and it can go till 128. That's the upper limit. Mm-hmm. It will not go. If we don't set this, if we set only the resource and don't set the limit, then the container can go up from 64 to whatever required. Yep. Cool. You're perfectly right. So it's basically telling why this is required, right? Now, who is doing the decision of placing these containers on a compute is a kube scheduler. Now, what kube scheduler sees is basically it does something called filtering and scoring, and it says, hey, there are 6 nodes. Out of 6 nodes, where I can place this pod, asking 64 MI of memory and 250 millicores. And based on number of replicas that you run, let's say 1 or 2 replica, it will say, okay, this is the aggregate resource. Out of 4 or 6 compute in my cluster, which node is the best fit? Basically, it's something called quality of service. It is guaranteeing you this much amount of resource. And for a memory-based application, it's always key to set a limit. If not, you can see either your node going into out of memory, meaning resource exhaustion of your compute, or let's say you set a lower value of limit. Let's assume you have set a limit here for memory of 128 MI. Now, let's say it's a Java-based application. It's doing something like a garbage collection in the end. What if it needs more than 128 MI? This container can restart for out of memory. So you're right in terms of setting request limit, but in terms of right sizing, again, coming back to that wheel, it goes through series of experimentation, testing, doing load test of the application, and then coming to the right value. I'll just skip this. We spoke on what requests and limiters. Now I'll pass it to Murli in terms of understanding how Guidewire went about right sizing or understanding the application profiling.
Thanks, Gautam, again. Okay, so we saw right sizing, request limit. Thank you for the insights. When we start cost optimization, right? Once we have tagging, once we have visibility, it always starts with, we don't have enormous amount of capacity. So we have one team in Anup's org, which 4 or 5 engineers who can focus on this. And you can't do too many things at the same time. So start looking at what's costing us a lot. So all the different dimensions that this is the actual picture, by the way, actual from several years back. So when we started, like many other companies, EC2 compute is our topmost spend. And then coming down to RDS is our second topmost spend. So that's when we started in employing some of the techniques. I would not go into the details. For people who understand insurance suite and Guidewire a little bit, I can give some examples. So again, bottom line, further to what Gautam also said, the right sizing is you have to know how to optimize, right? It's not just shrinking lace chips, then it'll be all, crunched up. So you have to figure out different mechanism of packing that. So that's the application profile that Gautam was also saying, right? So if you want to decide how much you want to optimize, then it starts with shift left from all of you who are developing the applications. Gautam talked about it, so I'm not going to take time. So what we started looking at, what I call is like eliminating waste. One is the right sizing, optimize your CPU memory. The other one is, Anup will also talk about it, is about application hibernation. In many of the development ecosystem, it may not be true across the globe, but for many companies, if they're operating, the development workforce is, let's say, primarily in one particular time zone. Let's say primarily it's in India, or primarily it's in US. As a developer, I come to office, let's say 9-ish, I leave, let's say 5-ish. Not we are expected to work later in the night. So predominantly, the application I have deployed, I have used it during the day, but don't expect me to stop the application. Let's say for whatever may be the reason, which is true for insurance suite to some extent. Insurance suite is a massive providing an industry value. So it takes about, let's say, 5-10 minutes to start, example, right? So I, as an engineer, as a developer, I don't want to come in the morning, start my application, wait for 10 minutes. I want to go back right after stand up and start progressing from where I left, right? So many times it's also a hassle to remember this, to stop the application, so on and so forth. So what we have employed, a way to stop insurance suite, and again, we can extend this concept for any workload also, where we stop at a particular time, 6 p.m. is what we picked off your time zone. And we start around morning time, let's say 7 or 8 a.m. So that kind of, a way to reduce the wastage, right? Likewise, when you're stopping the application, maybe the application is associated with RDS database is just an example I have taken, and which is what we have done. But you could have a similar examples which are costing high. Again, like I said, compute and RDS was taking much cost. So we started working on compute, stop the waste, and likewise stop RDS related waste. And keep going. So this is again an actual picture. I did not show you the actual numbers, but actual picture from us, where we started doing the interceptors model. When I touched upon kube cost, it can automatically resize to the CPU and memory by a single press button. But we have employed different techniques to do it. But if you can do some sort of an optimizations automatically using interceptor as you own the platform. And additionally, what I call the IS insurance suite hibernation and then RDS hibernation, we are able to reduce cost to a reasonable extent to make a impact. This is one of the another way to visualize the cost of a single particular application. So a sample application is what I have taken in a non-production development ecosystem, let's say, right? To run one of your particular service, insurance suite is an example. To run insurance suite, think of it this way, right? You're developing an application, developing a service. First of all, go figure out how much it costs. Go figure out your compute, your RDS, anything else, right? Anything and everything that costs money with kube cost or equivalent tool, you can figure out the shared cost and so on and so forth, working with the right teams or working with the platform teams. So I identified, let's say, $373 to run my application, let's say for a day, example. So what we mean by the unit cost is, you don't need to worry about you as an individual owning a particular application. How can I save everything, right? You don't need to think about saving the whole thing. We are all coming together in this goal of reducing cost. So I am spending $373 today. by learning all these techniques and the ways how we can optimize, how can I gradually reduce my usage? So reduce unnecessary CPU, reduce unnecessary memory, or when you're running your containers or database or equivalent workloads. So we have seen a reduction in unit cost. Imagine this is for one of the app deployments, right? In our ecosystem, Insurance Suite, at least there will be like 5,000 plus deployments running in any given day for different users, different usages, different scenarios for different customers. So that's how we are able to optimize cost across the board. So with that, I'm again going to hand over to Gautam to talk about some of the scaling and efficiency part. Thank you.
Hey, thanks, Mukul. So we understood optimization. Now, there could be a question, hey, why auto scaling is key? So we understood you're running your workload, optimizing your resources, visibility, monitoring. Now, the next key thing is where you run your resources is the instances or the worker nodes or compute, right? There was a slide which Murali showed on end of business. I don't want those compute to be running. So that's where your auto scaling is key. Now, before going into the compute auto scaling, we'll sort of step back, understand for the folks who don't know what are the different scaling options that you have in Kubernetes. One is your workload auto scaling. When I say workload, your actual microservice, containers, or pods. Now, how do you go about scaling it? You have something called horizontal pod autoscaler, where it adds the containers or microservices horizontally, meaning number of replicas can scale from 10 to 100 based on a specific metric. You need a metric store, which would be running as a metric server as a deployment, which would take the aggregate, hey, this is the application. Over time, let's say it's 70% aggregate on CPU. Let me add more containers. Now that's scaling horizontally. The other way of scaling your workloads is vertical pod autoscaler, meaning instead of adding more replica, you basically resize your existing container. So me and Anup had a talk offline, like in terms of VPA, he'll speak that in a bit, but it's going to basically resize your container. Let's say it was asking 1 core of CPU. Now you set a metric stating, hey, this is the CPU or memory metric that I'm defining. CPU, let's say set to 70%. If it breaches, it's going to resize that 1 core of CPU to 2. In terms of that, it's going to restart your container, but taking care of application availability, you have different mechanisms. But high level, these are the two scaling solutions that you have for your workload. Now, as and when we talked about horizontal pod autoscaler, it's going to add more pods. Now, who is going to add compute for that? Now, let's say 100 pods were running 10 a.m. in the morning, then 10.5, you have 1,000 containers coming in. You don't want your platform SRE teams to add instances or nodes manually, right? You need a scaler or an automatic way of scaling your nodes. That's where cluster autoscaler works. From the slide that you can see, as and when pending pods are there, your scheduler will tell, hey, I'm just having 10 nodes. I cannot place these incoming pods. Your cluster autoscaler running within the cluster will say, okay, I need to provision nodes because there's no compute within the cluster. In terms of how it's going to add the compute, this is step-by-step slide. Let's say the incoming pod is pending and your scheduler says, hey, there's a worker node, I cannot place that container. Your autoscaler will talk to autoscaling group. That's what you associate your EKS nodes with. You call it as node groups, but it eventually talks to the autoscaling group. It does the discovery through tags and it says, hey, let me increment +1 or +2, add a node, and as and when new node comes in, the pod lands there. Now, we understood cluster autoscaler. Now, how do I go about optimizing the compute? With cluster autoscaler also, you have different strategies in terms of setting right expander or scale down mechanisms. I'm not covering that. Here, we'll sort of touch upon something called Carpenter and how scaling is effective or it's little different than cluster autoscaler. So for the folks who don't know what Carpenter is, for the folks on the Zoom and on the room, so Carpenter is an open source tool that basically provisions and deprovisions compute for your Kubernetes cluster, in this case, Amazon EKS. The high level difference in terms of cluster autoscaler and Carpenter is there is no autoscaling group here. So there was a question from Murli. He said, hey, the predominant problem that comes from the application team is what is the right compute I should choose? Should I go with M series? Should I go with R? Should I go with C? Natively, let's say you're leveraging autoscaling groups, you interact with your platform team and say, hey, give me C series or give me M series. That is sort of taken care here by Carpenter. You need not worry what compute to choose. Thing as an end user or an application developer you should worry about is setting a write request. So based on application profiling, let's say you go about setting a write request, Carpenter is gonna talk to the entire EC2 fleet and provision a right compute for you. Now, maybe this slide would help you. Same pending pods. So instead of cluster autoscaler, you have Carpenter, but there is no autoscaling group, but it's going to provision a right node for you. Now, at the high level, how it is doing it, there's a custom resource file that you would run, but it's going to talk to the entire EC2 fleet. Now, if your application is CPU intensive, you're asking 4 cores of CPU, there is high probability for the Carpenter to provision a C series instance. Now, if your application is asking memory request, there are probability it's going to aggregate, hey, there are 10 replica. This is the core or memory I need. It will bring M or R series for you. I'll not go in depth on Carpenter, but more about how autoscaling can help optimizing cost. One of the key feature with Carpenter is scale down. So we spoke on scale up or provisioning, but again, coming to the hibernation or scale down of your compute end of business, consolidation is a feature where Carpenter can do something like a multi-node. So in this case, there are 4 compute, and the third and fourth compute, there are just 1 container running. It's a waste of resource of 1 M5 or 2 M5X large machine just to run 2 containers, right? So what Carpenter would do, hey, I've enabled consolidation. I'm setting a parameter called when underutilized. Now let me move those 2 containers to the existing capacity. So it's going to delete the compute, which is underutilized, and move your containers to the existing capacity. So this is something like a multi-node consolidation. Now, if you have a question, hey, I'm already using cluster autoscaler, does it not do this? The answer is yes, it does something similar, but it is associated always with the autoscaling group, and there are probability that it can scale down a different node group. Let's say you have one as an infra, one as an application node group. It depends on different parameters like scale down threshold or your expanders for scale up. Now, we understood, hey, it does multi-node consolidation, but where it is doing optimization. So Carpenter has this feature of replacing compute as well. For example, in the same use case, let's say your workload scaled down. Again, you're running 1 container on each of the compute. It can bring up altogether a different node for you. Basically, it's going to deprovision the old node. Your workload is going to move to the existing capacity or a new compute altogether, which would fit those 2 containers for you. Now, this is a key thing with Carpenter where it can help you optimize your compute cost. In the end, there's a case study that I can speak on, one of the customer use case where they've optimized some good numbers in terms of leveraging Carpenter and consolidation. But high level, these are the concepts specifically in terms of optimizing cost and scale down of compute. Cool. Again, comparison between cluster autoscaler and Carpenter. Here it is dependent on autoscaling group. It waits for the autoscaling group to do a +1 and +2. Whereas Carpenter just watch the pod, evaluate the scheduling constraint, provision the node, schedule it, and remove it when it is unneeded. Cool. Yep. With this, I'll pass it to Anup. He'll speak on the roadmap.
Thank you, Gautam. Can you wait till the end? We should be done soon. I'll try to go fast on the roadmap on what we are planning to do in terms of optimizations. The first optimization that we're planning to do is on networking. I don't know how many of you guys know about Istio. We use Istio extensively, mostly for doing mutual TLS. It runs as a sidecar or as a proxy. So for every application that I've deployed in Kubernetes, I have a proxy that sits in front. For every request that gets in, it goes to the proxy first and then goes to the app based on certain rules and configuration that we have set. Now, imagine this. It was okay when we had 1 cluster and maybe 10 workloads. We are upwards of more than 100 clusters now running tens of thousands of workloads, and the sidecar itself is becoming a bottleneck for us in terms of resources. So we're planning to move towards a more eBPF or extended Berkeley packet filter based network overlay called Cilium. So the idea is whatever we could do with a proxy, we could actually build it through Cilium into the container's kernel system itself, right? That's eBPF, which is a very exciting technology. I think all of you guys should read up about it. It's going to be amazing for the next few years. It's very early days. But since I have to talk about other things, I'm cutting that short. So we're moving there, which will essentially cut off the need for sidecar proxies. And that, at my last count, was a 6-figure number that we could save. not small, in dollars, not rupees. The second one is about optimizing the resources that we use ourselves in terms of CPU, right? We've been using mostly x86 and ARM-based uh, instances, and now we have a new CPU architecture from AWS called Graviton, which in most cases runs at 40% is peak reduction in cost, but you should see some amount of savings. Now, again, think of it in terms of, your running costs are in tens of millions of dollars. That is not small. Spot instances. So for those who don't know what spot instances are, is that Amazon provides a fleet of EC2 instances that have no guarantee that they're going to last forever for you guys. So you could reserve and pay higher for an on-demand instance and say that, hey, I want these instances with me. Don't take it away from me, and I'm going to pay you higher. You're reserving it, right? And the second is you have spot instances in which you say that, hey, I'm okay with a little disruption because either my architecture is great and can support the disruption, or that you're okay with the cost differential, in which case spot instance can come to more than 40 or 60% in some cases of cost. So we're trying to explore that in our non-production instances. So that'll help us reduce quite a bit of cost on for the customers as well as for ourselves. That, again, coupled with Carpenter, should give us a good way of how node scheduling and everything happens. Overall, we can optimize on those levels. Showback, thanks to KubeCost and whatever that you saw from Murli, we've done a lot of those things, but it's barely scratched the surface in terms of usage. So our main aim now is to get to a point where we can actually create budgets for each departments, talk to your L3s, and then be able to review and show back the cost and determine where the thresholds are going in terms of resource usage. And that this will also help your leaders ask questions on optimizations or ask for more funds based on the type of work that they're doing. And they are aware of where the cost is coming from. So the next one is scale to zero. We've all talked about microservices, and that's all great. It's always running, amazing. But are there requests coming to it every time? Probably not, right? You get probably, I don't know, 1,000 requests in a day on some, and maybe 1 million requests in a day for some, right? For the ones that only get 1,000 requests, it's going to be interspersed well within a day. Why do you want that microservice to be running it all the time? So we're looking at options through Knative or KDA, which are both Kubernetes ecosystem tools that will help us reduce or scale the deployment down to 0 instances of the application and bring them back up when there is a request that comes in. Of course, there is the question of cold start and at what level you need to warm up. Maybe you have to keep one instance depending on the type of application that you're using. But if it's dev, do you care so much? Now, while that's great, in many cases you have to run it in most times because you do not know the schedule better, in the sense that applications are getting requests mostly during the daytime. In some cases, right? It's not all over the day. And there is no request at night. And Murli mentioned about a tool that we built internally about scaling down at night or during schedules. We built it internally, and then we found out there's a better tool in the market. It's open source. Again, so it's called KubeGreen. So the next one is we're going to be evaluating that. That helps for all of you developers to do self-service in much more easily understandable Kubernetes native way. Container native database. Now, I think this might be true in most cases for other companies as well, but at least for us, the cost of EC2 is pretty much the same as the cost of our RDS databases that we use. And that's because we provision them exactly the same or similar in both production and in dev. In many cases, to just test your function, all you need is a Postgres database. You do not care about whether it's RDS, whether you use all the bells and whistles of RDS, right? And so we're looking at cloud native Postgres, which is like a container-based solution that you can run and schedule in Kubernetes. And so it has all the abilities to scale down, vertically scale up or down, etc. And that should help us, apply all the constructs for reducing costs at the Kubernetes level for that solution as well, while we continue to keep using RDS for production, performance, environments, etc. Last one, vertical scaling. This is the one that Gautam mentioned about VPA. The problem with VPA that we have right now is that VPA, when it looks at how much resources your container is using, and then recommends a new resource setting. The problem with that is that with every resource setting, it changes. It's going to be a restart of that container. We can't afford that for Insurance Suite, which is our core application, which is a monolith, and restarting every now and then is going to be very problematic for its users. But we have hope. Kubernetes in version 1.27 has come out with what is called in-container updates, which means that you can update the resources used by a container, and that doesn't need a restart. There is still a scheduling problem that needs to be solved, but if the node has resources, it will not restart the container. That is something that I'm looking forward to EKS to make that enable, because right now it's in alpha feature capability, and EKS does not allow alpha, only allows mostly beta. But I've been talking to Gautam on how to make that available through EKS, so we could actually make use a lot, which eliminates the need for you guys to have to think about what should my right sizing be. You can start with the same default and let the system grow and reduce as needed. Next, passing to Gautam.
Thank you. So we understood what are the roadmap for Guidewire, but just wanted to speak on some of the case studies, both in terms of scaling your compute and scaling your workloads, how it has helped different customers in terms of optimizing cost. The first case study here is, again, there's a reference. You can take a look at it. It's publicly available. I just picked one. There are a lot of case studies on customers adopting Carpenter with Spot, without Spot, and how it has helped them. So the challenge for Airtel Wink was they began experiencing high variable workload. These applications are very intensive in terms of scale up and scale down, and they wanted compute to be available in within few seconds. How it helped by moving to Carpenter was, one, there's no auto scaling group. You have scheduling latency or the pod scheduling latency reduced. And in terms of reducing the infra cost with Spot, Airtel Bank was able to reduce around 47%. And in terms of scale down and scale up, those are the numbers. Like from 2 minutes, they went to 40 seconds for scale up. And for scale down, they went from 1 minute to 20 seconds. And goals achieved high level was they were able to reduce the cost, improving their elasticity in terms of leveraging Carpenter, and also they were using Spot with prod and non-prod clusters, which again, you have it in roadmap. We can work on it and see how it's going to benefit Guidewire. Cool. That's on compute, but this is one of the key metric or graph that I wanted to show. We understood HPA, VPA, your workloads are predominantly on VPA, but let's say there are some workloads which are dependent on horizontal pod autoscaler. This is one of the customer case study where they were scaling on CPU. If you can see the time frame, during start of business, they start with around 100 pods, it peaks to 250, and within few minutes, it drops to 50 pods. Now, how this will impact your compute is like as and when your pods go down, be it be Carpenter or cluster autoscaler, it's gonna reduce your nodes. Again, it peaks, it's gonna add node. So in terms of scale up and scale down, it can directly or indirectly affect both your compute and in terms of optimizing how much resources you're using at the compute level. Now, what is the optimization that we helped customer was, hey, does your workload really need CPU metric to be scaled? Can we evaluate different metrics? Now, before I go there, question for the folks on the floor, whoever answers, you will get a goodie, would be in terms of with HPA, what are the different metrics that you can scale with? We know CPU memory, but have you seen any other metric that HPA would allow, if anyone can speak up or answer those? Sorry? Request is more of setting at the container level, but I'm looking at a metric. For example, scale. No. I'm looking for a key thing within Kubernetes, or maybe I'll put it this way. Horizontal pod autoscaler has an API called V1 and V2. Initial days we were using V1, today it's V2. With V2, you can configure different metrics. One is CPU memory, the default, but there are other metrics that HPA allows. So just trying to understand if you're aware of that. Cool, no worries. The other metrics that HPA by default allows is custom metrics or external metrics. Now, let's say I don't want to scale on CPU. I want to scale on a request count. Let's say I'm exposing my application with load balancer. I'm hitting X amount of requests on the load balancer. I want to scale on that. You can tune HPA with custom metrics and external metrics. We helped customer to scale with a different custom metric that eventually brought down their scale up pattern. And in terms of running number of nodes, it reduced drastically for them. So this is one of the key thing. Again, you can evaluate how your workloads are being scaled and then test, do you really need to scale on CPU or memory or any other metric? On top of what Anup spoke, that's there in roadmap, KEDA and other things. These are the options that you have. The snippet there on KEDA, like Anup called out, you can scale down your replicas or your instances of application at a specific time frame. Let's say end of business, you don't want 1,000 replicas, you just want 20 replica in your dev. You can do that. You also have different options like doing something like a batch scheduling, or there's a tool called downscaler, but KEDA works effectively better. Cool. This is what I wanted to cover. Thanks all for your time. I'll pass it to Anu.
Who can help? Okay, this is a question I'm looking for an answer. Exactly. He gets a goodie. Finally. But yes, this is nobody else. It's ourselves. It's about thinking when you're doing something, how is it going to affect your cost profile? Asking the right questions to the source of where a problem is starting, or an issue or created, or a feature being developed, right? Shifting left and building that non-functional requirements all the way upstream to make sure this is a conscious decision that we do. Well, there you are, Arun. So you can have a large buffet, no, but you should be taking care of your calorie count, right? Your health. It doesn't mean that just because I have a large buffet, I'm going to eat everything that's available. And just because it's unlimited, I'm going to stay there all through the day, right? You do want to set limits for yourself. You do want to understand where you can help improve your organization's profile of cost. And as a culture, this is something that you should all imbibe and ask each other. And as a team, it is calling out in a way, but it is necessary to grow as a business. With that, I'd like to thank all of you here and on the Zoom for being patient with us, being available for this more than 1 hour of talk. I hope it has been enlightening, and I hope it's going to help you as you move forward in whatever work that you're doing. More than anything, I'd like to thank our AWS partners, KubeCost, my co-presenter, Murli, Lakshmi for organizing everything, and also the teams who have helped build these things within Guidewire. Some of them my teams, the users among all of you guys as well. Thank you all. This has been amazing.